Alright, this video is going to be a review of trig ratios and then also the unit circle. So if you recall from trig, we often remember the ratios using Sohcahtoa as kind of a, not really an acronym, but kind of like an acronym for it. And the trig ratios, in case you have forgotten, are based on a triangle, and it's always a right triangle. Sometimes people call this right triangle trig. And with the right triangle, we have to have a reference angle that all these ratios are referring back to. So I'm going to go ahead and put theta as my reference angle, and I'm going to put it right there. And then all the sides are labeled based on their relationship to that angle. So this side is the longest side regardless, so that's always going to be labeled as the hypotenuse of the triangle. But then the other two sides will change depending on if you're talking about this angle right here or this angle over here. So here's the reference angle, the side across from it or opposite of it, we're going to name as the opposite side. And then the side that's touching it is going to be the adjacent. So sine of that reference angle is opposite over hypotenuse. Cos of that reference angle is adjacent over hypotenuse. And tan of that same reference angle is opposite over adjacent. So whenever we talk about these trig ratios or this trig function that we evaluate, the answer to that is always a ratio of two sides of a triangle. So I know that the ratio for sine has to be a number that's less than 1, and that's because the hypotenuse is the longest side of a triangle. And so I'm always going to have the longest side right here and then something shorter than that right there. So my numerator should be smaller than my denominator. The same thing happens with cos. The numerator should be smaller than the denominator. Tangent is the exception to that because the opposite and the adjacent don't necessarily have size restrictions in comparison to each other. And so that could be a number that's less than 1 or greater than 1. You have lots of options there. And then there are three more trig functions. So we have cosecant and secant and cotangent. And each of these is just the reciprocal of the other. So cosecant would be hypotenuse over opposite. Secant is hypotenuse over adjacent. And tan is adjacent over opposite. Did I say tan? I meant cotangent. I don't know what I said. Alright, so just to recap, trig ratios describe ratios of sides of a right triangle. And the trig function itself tells you which two sides you're working with. So sine tells you two specific sides, cos would tell you something different, tan tells you something different. So that's the importance of the different trig ratios. There is no such thing as just saying sine equals a number. There's no such thing, because we always have to talk about sine in reference to that angle that its measurements are based off of. You can't do sine if you don't know what angle you're talking about, because if I was to take this same triangle and put the reference angle over here, then the adjacent side would actually be the opposite side in this other situation, and the opposite side would become the adjacent side. So I have to specify which angle in the right triangle I'm talking about, or it doesn't make sense. So whenever you see sine written, it should never just be sine, it should always be sine theta, or sine beta, or sine of x, or whatever variable you're happening to use. Alright, so when you do sine of an angle, I'm going to go ahead and erase this because we typically want theta to be an angle. Whenever you do sine of an angle, your answer is always going to be a ratio. Always, always, always. And if you want to solve for the angle instead of for the ratio, if you want the angle to be your answer, then you would do sine inverse on each side to get rid of sine. And then you could say that sine inverse of the ratio would give you the angle. So if you have two sides of the triangle and you're looking for the angle that they were in reference to, then you could solve for that. but you have to have one or the other. You have to have the ratio or you have to have the angle. Alright, so that's it for the ratios. The next thing I want to talk about is the unit circle, and it still has to do with those ratios because the unit circle is kind of constructed so that we can remember common ratios for reference angles that are nice, like a reference angle of 30 degrees or 60 degrees or 45 degrees. And then we build these reference triangles inside a quadrant system where you have a first and second and third and fourth quadrant, and then you can start to refer to reference angles where your triangle might have a negative side just because that side of the triangle happens to go down or something like that. And so that's where all those other numbers come from. And it allows us to evaluate sine for something like 330 degrees because we now have a reference triangle that's in the fourth quadrant. So that was a lot of talking and no pictures. That might not have made sense. But we're going to go ahead and draw this sketch. And I just want to remind you guys of where the unit circle came from, because at this point you might have memorized it, but maybe you have forgotten where it came from originally. So I'm going to go ahead and draw a 45-degree angle right here. So here's theta, that's my reference angle right there. And I'm going to say that's 45 degrees. Because this is a unit circle, the hypotenuse is always a length of 1 unit. Alright? And then right here, I'm going to call this a length of x, because that is the left and right side of the triangle. And then I'm going to call this value right here y, because that's the up and down side of the triangle. Alright? And then over here, we're going to draw a little picture. Depending on how the curriculum was changing as you were going through the system, you may or may not know that there's a relationship between all of these sides. So if we have a 45, 45, 90 triangle, then these two side lengths end up being exactly the same. And this side length is whatever a times the multiplied by the square root of 2 would be. So in this problem, if I wanted to know what the sides would be on this triangle, and I know that the hypotenuse is a length of 1, I would say 1 is a multiplied by the square root of 2. And then to solve for a, I would divide by the square root of 2. So a equals 1 divided by square root of 2. And so both of these two sides would be 1 divided by square root of 2, and that's what the x and the y happen to be over here. And but we would say, oh, that's not proper. You can't leave a square root in the bottom. And so I'd go ahead and fix it. I'm going to rationalize the denominator. And so that leaves me with root 2 on the top and 2 on the bottom, which hopefully you'll recognize from the time that you've spent looking at the unit circle. So that would mean that my x value right here is root 2 over 2, and my y value right there is root 2 over 2. And so if I want to write down a point right here that represents how far right and how far up I've gone to get to the edge of the circle, then that would mean that that point is at root 2 over 2, comma root 2 over 2. Alright, and that is how the unit circle is constructed. So I'm not going to go through all of them. I just wanted you guys to know where those came from. So really, we're talking about a reference triangle here with an angle, and it has a hypotenuse of 1, and we have used something that we know about a special right triangle to solve for those missing sides. Alright, now a couple things I want you to keep in mind is when you look at this triangle inside the unit circle, you're going to see that if you were to do sine of that reference angle, it would be opposite over hypotenuse, which is y divided by 1. And so that means that the y coordinate right there is the same as if we said sine of that reference angle equals that ratio. So this is a ratio of two sides of a triangle. Now the two sides of the triangle we could say are 1 over root 2 divided by, what is that, 1 over root 2 times root 2. That would be 1. That's your unit, your hypotenuse of 1 right there. Or we could phrase it like this. We could say that the opposite is root 2 over 2 divided by 1, so this is the opposite side and this is the hypotenuse. Or we could talk about a different triangle altogether where the opposite side is root 2 and the hypotenuse is 2. And it doesn't matter which triangle we're talking about, all of those would have a reference angle of 45 degrees. So that ratio, that particular ratio of those two sides always means that the angle in our reference triangle would be 45 degrees right there. We can also look at cos of that reference angle, and we're going to get adjacent divided by hypotenuse. And so that means that the cos value there is whatever the x-coordinate happens to be. And then tan of that reference angle, opposite over adjacent, would be y divided by x. Alright, so here is my unit circle, and what I usually do, and if I was you, honestly, I'd go Google unit circle and copy it down or print it or something, because if you don't have this memorized still, it would be beneficial for you to have that memorized. Whenever I have a unit circle, I always write this down, that cos is the x-coordinate and sine is the y-coordinate, and then I remind myself that tan is the same thing as sine divided by cos, which is the same as y divided by x. And the reason I do that is because these little shortcuts are beneficial for you remembering how to evaluate trig functions. And when I evaluate the trig function, basically what I'm saying is, at that angle, what's the ratio? So one type of evaluation I might do is I might say, I'm trying to evaluate sine of 5 pi thirds. So I'm saying if I was to draw a triangle in the fourth quadrant, because the fourth quadrant is down here, then my triangle would be right here, and there would be my reference angle. And if I want to know the ratio of the opposite side of the hypotenuse, the ratio would be this y-coordinate here, which is negative root 3 over 2. Oh, you could not see any of that, so sorry. So negative root 3 over 2, that's my opposite over hypotenuse. And the reason it's negative is because in this quadrant, my opposite side right here is a value that's y that's going down. So opposite over hypotenuse. So I could draw a triangle where the opposite side is root 3 and the hypotenuse is 2. And that would fit this angle right here. It would measure the right thing. Let's say I wanted to know what tangent of 180 degrees was. Then I could go back and look at my unit circle, and I know I'm going to do y divided by x. And so over here I would look at the y value and the x value, and I would do y divided by x. So I would say 0 divided by negative 1 is 0. And I would say that that right there, we're not going to be able to make a triangle from that. That would have basically been a straight line. So we can use these ideas of evaluating where we understand how the triangles work, and we can extend that knowledge to maybe do problems where we couldn't draw them as easily. Alright, next I want to look at some trig functions when you graph them. So here is the form that we would look at when we graph them, and I just want to remind you, when we do sine of something, that number that we're doing the sine of, that would be an angle. And when we get an answer for that, that answer right there would be a ratio. So that means that when we're looking at these axes, we're saying, that's pi, then this is pi halves. So I'm saying that at pi halves as the reference angle, the ratio of my sides is 1/2. And if you look at your unit circle, and you see pi halves, or not the ratio of the sides is 1/2. The ratio of the sides is 1. I wasn't paying attention to my units. So if my angle is pi halves, then the ratio of the two sides is 1. So here's pi halves, the ratio of my sides is 1. If I'm looking over here at pi fourths, the ratio of my sides is some decimal that's closer to 1 and bigger than 0.5. And if I look over here at pi fourths, then I'll see that the ratio of my sides is root 2 over 2, which is 0.707, I believe. Don't quote me on that, I could be wrong. Alright, so if you want to know how to graph the sine graph by hand, all you need to do is use these values as your x's and use these values as your y's. Because you're saying when I take the sine of the angle, as my reference angle, here's the ratio of my sides. And then you can go ahead and just draw the graph. And that's why you'll notice that the range of a sine graph is between -1 and +1, and that's because the ratio of the sides of your triangle is always going to be less than 1, because it's the opposite divided by the hypotenuse, and the hypotenuse is the longest side. So same thing with cos. Here our curve is just shifted over, and that's because the numbers are not in the same order, so they follow the same pattern, they're just not in the same order. And again, you'd find them a similar way. And then that's why tangent looks all crazy, is because with tangent, you don't have that restriction of opposite over hypotenuse or adjacent over hypotenuse. You have ratios that could be bigger than 1. And so that's why you notice that you've got these numbers. And then we also have these asymptotes in here. And if you guys recall, the reason you have an asymptote in here at pi halves is because right here, if you were to try to evaluate tangent at pi halves, you would have to do 1 divided by 0, which is undefined. And so that's how in the tangent function you have some vertical asymptotes there, because you have some values that are undefined. Alright, so I know this video isn't perfect. It wasn't meant to be an introduction for the first time, but I'm hoping that if we start to see things about trig functions in the future, that will help you maybe remember some things and not be so rusty.